Welcome everyone. This is Amitabh Saxena, and I'll be your trainer. I'm a chemical engineer, and I've also worked in lots of organizations, uh, and that also includes lots of project consulting. I'm also a PMP. I'm a MBA Finance, and I'm having 30 years of experience in managing Lean and Six Sigma projects, and also conducting training programs for the last 20 years in various organizations around the world. Let me talk about a little bit of our organization. We are uh, an organization 15 years old. We started in Europe, but we quickly spread out in right from Canada on the west to even a little bit of Russia on the east. And we have done training programs worldwide, trained lots of people. I won't go into the details because now we have got only 2 hours. So I need to give you as many tools as possible. But prove that we have done training programs worldwide, I have some photographs for you. This is London training, and this Bangalore and Mumbai. And this is my first ever training uh, in fact, it was not only my first ever, but this was the first ever training, black belt training ever conducted in GCC, any of the GCC countries. And this was the black belt training. Simultaneously, it was done for Saudi Engineers Forum, plus also a group of doctors. So there were two parallel batches running in 2008 when I launched the Lean and Six Sigma trainings in Middle East. And that happened in Riyadh, incidentally. So we have, anyway, lots of presence in UAE as well, and lots of companies in Saudi Arabia have been our clients. And, we also consult for improvement projects. So not only we conduct the trainings, but also implement the Lean and Six Sigma. So so this is Pepsi in US, where they are learning a tool called FMEA, failure modes and effects analysis, and then won lots of awards in various forums, appeared on TV channels, and spoken in various conferences. This was the last 5 years. I have been invited by ASQ, American Society of Quality, world conferences to speak on different aspects of quality that most of the time includes Lean and Six Sigma as well. So this is one of the trainings.
On 21st of May 2019, I'm going to speak in American Society of Quality's World Conference in Fort Worth, Texas. I'm going to talk about how one of the fields in artificial intelligence, robotic process automation, or RPA, can be used to support process improvement initiatives along with Lean and Six Sigma. We will see how this combination leads to improved productivity, improved quality, and reduced costs. Using a case study from a bank, I will share a roadmap to leverage the capabilities of existing quality programs like Six Sigma with RPA to produce better results. So see you there on 21st of May in Fort Worth in Texas.
So I think now you're trusting me. Yeah, so what Lean and Six Sigma can do for the organization. So let us talk about that. So what Lean and Six Sigma can do? It reduces the costs, reduces the errors, reduces the wastes, reduces the rework, cycle times. So especially, I understand that many of you from projects, so it will reduce the rework, it will reduce the cycle time, and it will also improve the quality, production efficiency, productivity, and of course, internal and external customer satisfaction and profitability of the organization. So I think all organizations want this. So if you look at the capabilities of Lean and Six Sigma, it can do almost everything what the CEO would like to have. And they would like to reduce the costs, reduce the defects, reduce the waste, etc. And also, they would like to improve the efficiency, productivity, and customer satisfaction as well. Now, how is it accomplished? It is accomplished by doing projects. Whatever you want to improve, you convert those into projects. So whatever is an improvement opportunity in your organization, you would like to convert this into project. And many of you know, because you are from a project background, that definition of a project is that it has a starting point and it is an end point. So typically, Lean and Six Sigma projects, the quality projects, are done in 3 to 6 months. So within 3 to 6 months, you complete a green belt or a black belt project. So it all started in Motorola in late 1970s when Bob Galvin wanted to improve the organization by 5 times in the next 5 years. So he invited 2 engineers, Bill Smith and Michael Harry, to help him. And he was particularly interested in the approach what Bill Smith and Michael Harry used to follow. These 2 engineers, they used to convert the improvement opportunities to projects, and they would complete a project by using statistical tools and techniques. Especially the root cause analysis was of particular interest to him. So he said that you are just able to complete 2 to 3 projects in a year. I want 500 projects to be completed in the next 5 years. So how to do that? So Bill Smith and Michael Harry came out with a methodology called DMAIC, Define, Measure, Analyze, Improve, and Control, DMAIC methodology, which helped them to accomplish what the CEO, Bob Galvin, wanted. They first trained the green belts and black belts. And once the green belts and black belts were trained, they were allocated projects. So they identified the improvement areas in their departments. So procurement department would reduce the procurement time. The project implementation team would reduce the project implementation time, or a lot of rework in the documentation, back and forth, a lot of rework happens. They reduce the approvals. They used to have 7, 8, 9, 10 approvals at every stage. They drastically reduced the approvals by more than 80%. So instead of 10 approvals, they reduced to 2 approvals. So they started questioning each and everything. And once they questioned each and everything in the process, they came out with a better process. So that's what the history of Lean and Six Sigma is. And the whole world really listened to what Motorola did, and they wanted to replicate that. So that has been. Some of the companies where we have done. So I will just talk about some companies. Obviously, this will give you an.
The CEO of NAPL. Through Anexas, Mr. Amitabh has teach me and more than 1,000 employees of NAPL, Six Sigma, and Lean processes. This affected our bottom lines by millions of riyals, and it is having a big impact in changing our company from a local company to a regional or multinational company. Thanks to Anexas and Mr. Amitabh.
So this is just one of the credentials. We have got lots of credentials from SABIC, ADNOC in UAE, from Aramco, from Ministry of Health, and I have lots of people from SEC have even attended independently. They have attended our open house training programs. So as you could see that there were some projects we had completed over the period of 10 years. We completed lots of projects. And we have trained more than 1,000 employees there. In this bank, we again trained 100 employees, completed 40 projects over the period of 2 to 3 years. So it doesn't mean that you have to take this whole initiative for 2 to 3 years. This is Alpha Time Group. Again, lots of projects completed, leading to lots of savings. So each and every Lean Six Sigma project leads to some savings. This is again another organization, ADNOC, an oil company, where we completed a rig move. The rig move project is when the whole equipment, the machinery, is moved from one rig to another rig. So this was a project which was again featured in American Society of Quality and also ADIPEC conference in Dubai and American Society of Quality in Charlotte. So
4 years ago, somewhere in Middle East, one of the largest oil companies took up a Lean and Six Sigma project to reduce the rig move time from 7 days to less than 3 days. By doing so, they would increase their production capability without investing in additional equipment. I'm Amitabh Saxena from Anexas Consulting, and on 2nd of May, in American Society of Quality's World Conference, I'm going to talk about how around 50 people of different nationalities came together to solve a problem which was considered to be very, very difficult. In our journey, we used lots of Lean and Six Sigma tools and techniques, including the change management methodologies and advanced statistical tools. In our 10 years of existence, our company has completed many projects, but this project still stands tall amongst all of them, just like Burj Khalifa. So see you there on 2nd of May in Charlotte in USA.
So as you could see that again there we have completed lots of projects. So you could have now understood, and of course we have got lots of credentials, but I would not. Oh yeah. This is Ministry of Health, Saudi Deputy Minister of Health, who has also attended our black belt. So anyway, I hope you have understood that Lean and Six Sigma is applicable to all industries, be it engineering industry, be it construction, project management, be it services, be it bank, be it even the logistics industry. So how is it accomplished? So first, let us understand very, very briefly what is Lean and Six Sigma. So what is Lean and Six Sigma? Lean is about mapping the processes and also identifying the waste in the system. So first we map the process. So if I take an example of, let's say, installation of machineries, installation of transformers, let us say, first we will map the process end to end. And we have to map by doing Gemba investigation. Now, Gemba investigation, in Japanese, Gemba means go to the field. So that means don't sit in your office and make the process map. You have to go and check in the field how the things are taking place. Once you capture each and every step, what's exactly happening, we call it as is process map, then you identify the waste in the system. So here you are going to identify the 8 kinds of waste. Typically it is 7 wastes we say, but 8th waste has been added recently. So you identify 8 kinds of waste. Some examples of waste are intellect. Waste of intellect means you are not using the intelligence of present in the organization to the fullest. So that is one waste of intelligence. Maybe lots of engineers are not involved in the engineering related job, but they are, let's say if you're just answering mails, which can be done by any other person also, that means it is waste of intellect. If you are in procurement team and rather than managing the procurement, you are most of the time waiting for the approvals to happen or waiting for the queries to be replied. That is again a waste. So that is waiting time as well as a waste. Transportation, any transportation which is not adding any value is a waste. So there are 3 say criteria to qualify for a process step to be called as value added activity. If it is not done right the first time, it is non-value added. So if anything is done again, means you commit a mistake and you do something again, that is rework, or anything starting with the review, inspection, checking, all these are considered as wastes in the organization. So that is what is one of the wastes. Any over processing means too much of documentation, too much of inspection. Any inventory, like getting the machineries, equipment more than you require, getting the raw material more than you require, That means money is getting stuck. Your organization's money is getting stuck in that. So all these things contribute to waste in the process. So if you're looking at process mapping, identifying the waste, and doing ESCAP, applying ESCAP methodology. ESCAP is ESCAP, eliminate, simplify, combine, automate, and parallel. ESCAP, if you're applying that, and I'll show you that slide as well in a short while. So if you're doing that, that means we say you're doing lean. Then what is Six Sigma? Six Sigma is about reduction of process variation. Process variation in your organization. Process variation in all the specifications of your products. Process variation in all the services of your products. So can one of you tell, or in the chat box, that some of the processes most of the team is involved in? Or you can just, 2-3 people can write, or like what exactly they are doing. So based on that, I will take an example. Okay, building power plants. So that is one thing. Construction works. Very good. So Suraj is telling building power plants. Basam is telling construction works. Construction works for power plants. Very good. So let me take an example. Developing softwares. Excellent. So Sohel is from IT. Wow. So, but again, I make an assumption that most of you are from involved in projects, and especially most of you are involved in the different activities of construction of a power plant. So let us take any one activity which is repetitive. Most of the time it's happening, is very critical in your construction of power plants. Can you give me any 1 or 2 activities, 2 or 3 activities? Design PP. Okay, so many of you are involved in that. Design a power plant. Okay, and typically how much time it takes to design a power plant? Inspection of site activities. So I think inspection of site activities might be it's more repetitive in nature, I would say. So let me take that example. So typically one inspection of site activity takes how much time? Approximately 2 to 3 hours. So you have to go there and do the inspection, and you can, well, 2 to 3 hours is if it's acceptable by everyone, that's fine. But if you would like to reduce it further without affecting the quality, yeah, it depends on the type of activities, as you are right. So I'm just talking about, Salman, that the type of activities, what are the mostly occurring type of activities. So let's say, for the sake of taking an example, let us take that it takes around 3 hours. I could have taken the PowerPoint design also, but I'm assuming that that whole activity happens like few times a year, 1 or 2 times a year. So let us take some example which is repetitive in nature, and we can quickly create some good data about it. So it's, let's say 3 hours is the typical inspection time. Now, let's say your management says that 3 hours is very high. Or in fact, you say it's 3 hours, but when we start collecting the data, it takes almost, let's say, 1 day to complete an activity. Yeah. So we will do a Gemba investigation, and then we find that what we think is 3 hours is actually, let's say, 5 hours, which includes a lot of other things. Because from customer's perspective, and by when you get the report, how much time you give the report of your inspection. Okay, so now this is the real customer's voice. We call it voice of customer. So voice of customer, if I ask the customer, what do you want in an inspection? He would say, inspection should be done, and also the report should be generated. And let's say they say that, this is the end-to-end process. And now let's make an assumption that I collected 20 to 30 samples from your last inspections. And I found that some average of it is taking around, let's say, right from the site inspection to the report submission, it is taking, let's say, 30 hours, 30 hours. Yeah. Or if I say business hours, it is taking, let's say, so let's say 15 hours. So 8 hours today and 8 hours next day. So this is my 650. Now, your management says that I want the inspection to be done, a report also to be sent on the first, same day. So how would we improve the process? So here, let me take this example and I will try to explain the concept of first the normal distribution to you. And then after that, I will talk about the voice of process and also voice of customer. So let's imagine that we are right now we collected the data of, let's say, because of the lack of time, I'll just generate 7-8 samples. So one inspection was done and the report submitted in 12 hours. Another was done in 14 hours. Another one was done in 10 hours. One was 15, 16, and 12, and 10, and even 9. Yeah. So this is some time. So on an average, it is 12 hours. Now, Mr. Goss, he lived in 18th century, he found that all the repetitive processes in the industry, they follow normal distribution. It is known as normal distribution because it is normal to obtain a normal distribution. So we call it as a normal distribution. Yeah. So normal distribution. And all the processes are having two parameters. One is average. So in our case, in our data, average is 12 hours. And there is standard deviation. So let us say, in our case, the standard deviation is 2 hours. Okay. So he said, and he devised this theorem, it's also known as Gaussian theorem, that this is the probability curve. It never touches the z-axis. This is known as z-axis or z-axis. It never touches. It touches at plus infinity and minus infinity. But it appears to touch the x-axis at plus 3 times the standard deviation and minus 3 times the standard deviation. And so this is 1 standard deviation, 2 standard deviation. This is minus 1 standard deviation, minus 2 standard deviation. And this is the X bar, that is the average. So he said that 99% of the population, we are talking about the population, not the sample. Yeah, the population means all the inspections done by you would be within what range? It will be X bar plus minus 3 times the standard deviation. X bar plus minus 3 times the standard deviation. So let us do the calculations. So I got averages 12. Okay, 12. Then standard deviation, 1 standard deviation is 2 times. So here it will be 14, 16, and 18. And here it is 10, 8, and 6. So I can say some of the inspections and even reports are being submitted within 6 hours, maybe the same day, 6 working hours, right? Some go as long as 18 hours, means some are submitted even on the 3rd day, not even the next day or 2nd day, but even 3rd day. Very few, a few times it happens, but it happens. So this is my overall performance of the process. We call this as lower control limit, and this is known as upper control limit, LCL, UCL. And we also call this as voice of process, as if process is telling you, as the inspection process in SEC is telling you that I will behave between 6 hours to 18 hours. This is the way I behave. This is the way, I will continue to behave next week, next month, next year as well, as long as the systems, procedures, policies, the training provided to the people, the equipment, the softwares, everything, the whole system, as long as it remains the same, process is telling you that I'm going to continue to operate between 6 hours to 18 hours. This is known as voice of process. So if I just represent this here, so if I represent this here in the form of, this is lower control limit, 8 hours, upper control limit is, how much was that? Oh, sorry, lower control is 6 and 18. So here, 6 and 18, right? So 6 hours and 18 hours. So I can predict the performance of the inspection process. Like this. It will continue to behave like this. Yeah. And we say that process is under control, means it is as per the predicted limits. Now, these are predicted limits. This is known as voice of process. But that doesn't mean that your customer is happy. Yeah. Maybe, I'm just taking an example, hypothetical example, that your manager tells you, well, 6 hours, this is too much, and we need to close all the inspection within, let's say, 4 hours. Complete the inspection and submit the report. Everything has to take place within 4 hours. Now, this is a huge process improvement. It's like a breakthrough improvement. It will reduce lots of, project time. Your power plant project implementation plan will drastically reduce if you are able to reduce your inspection times. Because the inspection time, once reduced, will also going to reduce lots of subsequent activities, because many times we are waiting for the inspection reports. Then it is sent to some other place. Then other department acts on it. Again, there's a lot of waiting time, lots of things, lots of waste, we say. So he says, well, so this is known as specification limit, SL, specification limit. And let's imagine that this is 4 hours. This can be set by the customer. It can be sent by the external customer, maybe a government. Maybe tomorrow a government regulation comes that all inspections need to be completed by 4 hours, maybe. Or it can be set by the market, like your competitor is doing. In your case, of course, there is no competitor, but just in case. So your competitor is doing, you would like to, win over the competition. So in that case, again, you are having a set limit, specification limit. We call it voice of customer. Sometimes it's only, UCL or LCL. Here, one-sided limit, obviously, it can be less than 4 hours. But sometimes if you are in manufacturing, let's say if you are manufacturing, even in fact, I have conducted training programs for Siemens, and there we did a project, and I those days I did this around eight or 9 years back. Those days, definitely Siemens was a supplier of SEC. I don't know what is the situation today, but those days definitely they were. And a lot of examples we had taken, related to the transformation installation, if I remember correctly, and lots of projects which Siemens is doing in SEC. So we had taken some projects that time. That's what I remember. So here, the specification limit is set by the customer, external or internal. Now, if I apply the statistical thinking, a green belt or a black belt's thinking, a Lean Six Sigma thinking to the whole process. Suppose one day you took, or let's say in one project, or let's say last week, maybe this is the average of all the inspections done. And this one week, you received on an average, you took just 7 hours. This was the first time ever achieved. So we feel very happy about it. And maybe you celebrate this achievement with a nice coffee in maybe your cafeteria, or maybe in the 5-star hotels. Nowadays, this going to 5-star hotels is, well, looks like very old age because of this COVID-19 situation, but I'm sure that those days will be coming back again. So let's say you celebrated your achievement, but the next week it goes to, let's say, 8 hours or 9 hours. Next week it goes to 12 hours. Now you might think, okay, I think that celebration got backfired. People are now very happy. We're very happy, but now something is going wrong in the process, and you might be worried. You might be looking for reasons, but no. Statistical thinking tells you that this is any variation which is happening within this is due to common causes. Common causes. Yeah. Let me explain this a little bit more. If I make a cause and effect diagram, delay in an inspection. Can you give me a few causes? In Lean and Six Sigma terminology, we call these as X factors. X factors, X's. So I'm now seeking X factors. And whatever I'm trying to improve, I write it as Y. So can you please tell me what are the X factors which affect the delay in your inspections? That includes the inspection, some activities, inspection site of the site, plus so manpower, okay, manpower shortage, schedule problems, okay, schedule problems, work not completed by contractor. So I'll just say incomplete work. Okay. So maybe many times the inspection gets postponed. Yeah. Resource shortage. Okay. Any particular activity in inspection which you do at the site, which takes the longest time during the inspection, like do you meet or do you ask questions, or yeah, so here one is site not ready. Ready, okay. Can you tell me any two or three activities, like the 3 hours you said might be constituting like 1 hour of meeting, 1 hour of checking or inspection, or inquiring. So can you give me 2-3 basic steps in that? This also say writing, okay, report generation time. Can I say report generation time? That also contributes. Sometimes it takes more time to generate the report. Yeah. Documentation. Okay, documentation, incomplete documents. Okay, I think so. We have got incomplete documentation. I have got Anil with me, who would be capturing all these causes as X factors. So here I just added report generation time, and can I say, let's say, once you go to the inspection, do you meet the contractor? Do you have a meeting with them? So can I say meeting time also? The meeting time, meeting gets extended for 3 hours, 4 hours. He keeps giving explanations. The contractor keeps telling lots of excuses, and the meeting gets prolonged. So maybe that is one of the reasons. Okay. Now we have got all the not all the X factors. I've just listed some of the X factors, and once that is done, when all the common causes are acting on the system, little bit this report generation time, little bit of schedule problem, little bit of site not ready, little bit of meeting time, all these things we say are producing the common causes. So this natural variation, we call it natural variation of a process, is due to the commonly all the X factors are acting on your system. Commonly all the X factors are acting on your system and producing this variation. So that is what is known as common cause variation. So I will not tend to explain, or I'll not feel very happy at 7 hours. I will not feel very bad at 12 hours also. This is natural variation of the process. It is expected. But suppose one inspection took 40 hours, means a lot of inspections happen, rework. See, again, going to the site again for the same inspection is a rework, it's a waste. But many times you have to do because the site was not ready. Maybe contractor was not, or he was busy somewhere else. He did not report at the site, or the person whom you were supposed to meet is absent. Now here, if this happens, I can assign a special cause. This is known as special. I can assign, well, report generation took long time. I will assign one reason only, or it could be maybe documentation was incomplete. So when I go above and below, lower and upper control limit, we say there is a special cause. There is a special cause. So now we have to understand the difference. The green ones is the common cause, and the red one is the special cause. Now Deming, he was a quality guru, and he said, most of the time, the managers waste their time in managing common causes. And then there is no energy left when this happens, and then process goes for a toss. What does he mean? He says that, like, suppose 7 hours feeling happy, 9 hours, oh, worried, 12 hours, worry too much. Here you are trying to take some action, hold a meeting at 9. When it becomes 9, 7 to 9, you are calling a meeting. Hey, what happened? 9 becomes 12. Hey, something, some emergency meeting is called. And then someone gives a nice lecture on the urgency, etc. And then suddenly it reduces. You may feel that that lecture or that meeting helped, but no, this was supposed to happen. This was the natural variation. It did not have any impact. The meeting did not have any impact. That's what a Lean Six Sigma green belt or black belt would say. But suppose this happens, yes, it is happening due to, oh, just a minute. It is happening due to a special cause. Here the action is required. A special immediate action is required here, not in this region. Okay, so first, I hope I have explained it to you. Not in this region, but only here, a special action is required. But does it mean that you feel happy about it? Does it mean that you are very happy? If let's say this is not happening. Process is like this. Should you be happy? No, because customer is not happy. Customer wants within 4 hours or you yourself may want. Means you yourself want to improve the process. Why not? And the whole world is shortening their cycle times. Why not you? So here you would say, I would like to change my control limits, and my process should be behaving like this. New control, lower control and upper control limits, new ones, which are well within the specification limit. And this is what Lean Six Sigma can help you. Only DMAIC approach of Lean Six Sigma can help you reach here. Not a meeting, not a training, not some special expert comes and he meets and then submits a report. No. A very well structured Lean and Six Sigma DMAIC methodology, which of course now I'm going to tell about, is going to help you. Means you're trying to change the control limits. This was this was the DNA of your process. You were historically for the last 6 months, 1 year, 2 years, maybe 5 years, you are like 6 hours to 18 hours. Your process performance is between 6 hours to 18 hours. Now you want to change it to, let us say, 1 hour to 4 hours or 3.5 hours. It's a new control limit, totally. And you would like to sustain the gains also. It should not happen that 3-6 months you do a nice project, reduce it to less than 4 hours, and then you go back to the original state of average 12 hours after 6 months. No, it has to be sustained for a long, long time. That is what DMAIC or Lean Six Sigma project ensures. How does it ensure? Of course, by reducing the variation. Like here, if you see, variation is reduced, and also by shifting the mean. Here, the mean also has shifted, isn't it? So variation has reduced from 18 to 6 hours. It was around 12 hours variation, has reduced to 1 to 3.5, if you say 3. So it's 2.5 hours. So variation is reduced. And mean has also shifted. So all this together constitutes Six Sigma. And also, if you take the lean part of map the process, identifying the waste, which will also help you to reduce the cycle time drastically, constitutes Lean and Six Sigma. Now, how it is done? It is done by teaching or training the people in your organization. It is done by teaching and training the people in the companies. So some people can get in-house training, means a training company or a trainer like me comes to you, and then we choose projects let's say Mr. Zaki takes a project to a time. We would like to reduce the documentation time. We would like to Mr. Turki takes a project related to inspection, site inspection. Another maybe Mr. Salman takes up a project related to design. One of the design activities, designing a power plant, we have got very some calculations part is very critical, and it takes 3 to 6 months, maybe 3 months or 4 months. We would like to reach to 3-4 months to, let's say, 2 months. So everyone takes up different projects. And once everyone takes up the different projects, let us go back to the slide. Everyone gets the project, and then it is allocated to the green belts and black belts. So who are green belts? Green belts attend a 3-day training program, and they learn these tools and techniques. I just showed you some tools like cause and effect. I showed you, I think, control chart. I showed you histogram, the normal distribution. I talked about a little bit of waste, process mapping. So all these tools and techniques are taught to these green belts or black belts, and they take up the projects. They are allocated the projects. The head of the departments are known as champions. So you have a champion. Now they don't have to undergo any training, but sometimes we conduct a champions training for them as well. So if they are willing, well, half a day, just the way we are doing a training right now, it can be sort of champions training right now. So just to know what is Lean and Six Sigma, so that they can ask the right questions and they can support the green belts and black belts. They don't have to learn any tool, but they would be supporting the green belts and black belts. So champions are assigned to the projects. And then we have got steering committee. If the whole organization is very much interested in the whole implementation of your Six Sigma very seriously, then we form a committee with the senior management team, 3-4 people from they form a steering committee who will monitor this Lean Six Sigma implementation. And then we have got master black belt, like people like us, people like me who have a little less hairs and who keep talking about Lean and Six Sigma always. they will come and train you. They will come and guide you as you execute the projects. Now there are two things. Some people, like many of the people from SEC have come to our training center, and they have got this training, and they have also completed. Once you pass the exam, of course everyone passes our exam, so you don't have to worry about it. They also get a certificate. They may not do the project because we do a virtual project in the classroom. If they don't have a project, then they do a virtual project in the classroom. The way we are doing right now, a virtual project is the classroom. So they do that. So either way, you get a certificate. If you are in the organization, you do a real project. If you are not in the organization, you're doing as an independent candidate, then you do a virtual project in the classroom itself. And once you complete, you become a black belt. And of course, if you're doing in the organization, and if the organization has gone for Lean and Six Sigma implementation, then in that case, well, it also gets lots of benefits. Your cycle times reduces, your customer satisfaction improves, your efficiency improves, your power plant whole installation time, which was 1 year, or not like 2 or 3 years, it drastically reduces. Maybe just like 2 years reduces to 1 year, 1 year reduces to 6 months, so on and so forth. So this benefit is going to incur once you have got trained green belts and black belts in the organization and who understand these philosophies. Okay, I'll not go into the very much detail, but like for champions training or during our trainings, we design a game, with related to your industry. Like for example, this was in I think Switzerland, and here they are playing a game with respect to their industry. So they are applying these tools and techniques to their own processes, and in this case, they are trying to improve. 4 people at the 4 corners. They are acting as a customer, and they're sending some couriers to each other, and they're trying to reduce that courier time and also the errors committed, the wrong delivery, etc. They're trying to reduce it. So we designed this game for you, and once they apply these tools and techniques, they end up improving the process. So this is, and of course, once the training is done, I'll not go into the details of the implementation, but this Riyadh Bank is one of our clients. We did for 3 years, 2007, 8, and 9. Now this is just another example, but I'm just talking about Riyadh Bank. So typically 3 years plan has first year, you have green belts. We train the green belts. Then next year, we train the black belts. Sometimes green belts and black belts in the first year itself. They do some improvement projects. First project may not be that really giving you millions of riyals of savings. They may give you small, like 100,000, 200,000 riyals. The second year, you'll have millions of riyals of saving. And then last year, you yourself are trained as master black belts. By the way, we conduct green belt, black belt, and master black belt trainings also. We are the only company in whole of Middle East which conducts master black belt training also. And we have got franchises also in Saudi Arabia. So you have got lots of people doing training but taking certification from us, or they are associated with us. But right now you are talking directly to us. So last year we make master black belts, or even the second year we create master black belts in your own company, and they run the whole initiative themselves. So this is how typically Lean and Six Sigma is implemented. Now let me show you a project See, let me show you a simple process project, very simple project, which will help you to understand DMAIC. Define, measure, analyze, improve, and control. What are the basic activities happening there? Then from the same company, it's also a project oriented organization. So here, from the same company, I'll try to pull out 1 or 2 projects, but rather pulling out projects from them, I will rather apply or try to do a project in we'll continue with this inspection related project. We'll try to, implement that whole DMAIC to your own project. Either approach is fine with me in the remaining, say 1 hour of time. So right now, I'm going to show you DMAIC, the flow. So look at the flow. The purpose of showing this project is to tell you the flow of the DMAIC. So define, measure, analyze, improve, and control. These are the 5 phases. A green belt or a black belt applies to the project. So first you create a team. You identify the champion. Who is the champion? So head of the department, here in this case, the HR director. He's the head of the department. So he will be the champion. Then you have process owner. Here in this case, manager, process manager, recruitment manager will be the process owner. Who owns the process? In whose process you are doing the project? Then you have got the people who are doing the work. So that means the project, the improvement project, they are known as green belts. The first thing is you look at the process, the high level process map. High level process map means just make 5 to 6 basic steps. What is the output of the process? Who are the customers of your process? What is the input of your process? Who are the suppliers of the process? SIPOC, we call it a SIPOC. Yeah. So first we identify the customer. Like in your case, the inspection process, the customer would be maybe your project head, the person who is looking after the PowerPoint, the construction of the power plant, or maybe some of the managers. What is the output? Inspection, complete, or inspection itself is an output, or inspection report is an output. And the process, of course, you know the process better. So I'm not going to tell you that process, you know the better. So you'll be listing these 5, 6 steps. What are the inputs? In your case, it would be, let us say, the confirmation from the contractor that yes, we are ready for inspection. Some documents, you may have asked some documentation to be completed. That may be one of the inputs. And also, you can also put in the chat box anything you would like to share. So some of the inputs, if I'm right, are these what I just mentioned, and some other inputs maybe. So it will list what are the inputs to my inspection process. Of course, the inspector himself is one of the inputs, and the suppliers. Then we go to the customer and ask, how do you feel about my process? So in this case, the disciplines or the departments, they are the customers. So we ask them, how do you feel about my process? We ask about we ask the customer, how do you feel about my output? So here the output is recruitment. And they say, well, we are not happy with it, you take long time. So we convert these voice of customer into measurable characteristic. Measurable characteristics means we measure. We put a metric to it, right? So we convert voice of customer, which is in English or Arabic, we convert into a statistic, a measure. We call it a CTQ. Okay, so here the turnaround time. So if the customer is telling that, oh, it's taking a long time to recruit an employee, the turnaround time or recruitment time is the CTQ. In our case, in our project, the inspection time or the inspection time in the sense the full report, inspection with a report is my CTQ. So you write a project charter. After that, you write a project charter. So here, is the project charter. You write the problem statement, you write the goal statement. Problem statement means, what is the problem today? Oh, it is taking more than 60 days to recruit an employee. And I would like to have this to be done within 60 days. That is the goal statement. So problem statement, goal statement. In our project, it is taking around, on an average, 12 hours to finish the inspection along with the report. And I would like to finish this within, let's say, 8 hours or whatever. So problem statement, goal statement. And if I do that, so I'll mention how it is going to benefit my organization. So I will just mention, this is like a business case, why I'm doing this project. So after I do this, so here they have mentioned that, well, if you recruit the engineers faster, we will be able to put them on the projects, and they are billable engineers. So, well, every 1 day of delay is, responsible for the loss of revenue for this organization. Okay, so you write a project chart. That completes your define phase. So we completed so if you remember, 5 stages. So this is the define phase. We wrote a SIPOC, CTQ, and project charter. And one more thing, just to tell you, we believe as a green belt or a black belt that you cannot improve if you cannot measure. And the second rule is what we believe is everything in the industry can be measured. Everything in an organization can be measured. Now, you might wonder, how is it possible? So, well, it is very much possible by understanding the 2 types of data we have in this world. So, there are 2 types of data. One is continuous and one is attribute data. So continuous data can be represented on a number line. It can take a decimal place, it has a unit. Like, for example, inspection time. Inspection time is 12.5 hours. Yeah. So this is a continuous data. Yeah. Design time, 6.5 months. So this is design time. Then we have got documentation time. Okay. Documentation time. It takes, let's say, for a particular contractor to submit some documents which we are asking, he takes, let's say, 6 or let's say 8.9 days. Very long. We would like to reduce that as well. So that is another example of continuous data. So you see here, every time you have a unit and also you have a decimal point, possibility of a decimal point. You have a unit and a possibility of a decimal point. So that means it's continuous data. Continuous data, you can make a histogram and also you can make a normal distribution. So let's say inspection time, 12 hours, and you have got our values. Design time also will follow the normal distribution. Documentation time will follow the normal distribution. Experience of your engineers will follow normal distribution. On an like average experience or experience of an individual engineer, let's say, is 6.9 years. Again, the same thing, same story, decimal and unit. Now, attribute data is something which we think cannot be measured. Many times we think, oh, it's difficult to measure so many things. But here we are green belts and black belts, isn't it? So you can measure everything. So easiest measure of anything is any attribute is binary in nature. Like for example, oh, just before that, this is also known as quantitative data in usual terms. In statistical terms, we don't use this word like quantitative, but this is also known as qualitative data. Like in general English, we call it qualitative data here. Oh, I'm just writing very quickly. Otherwise, my handwriting is much better. I'm trying to, write as fast as possible. To maximum tools, I want to give it to you in 2 hours. So, okay, so attribute data, and then we have category. Yeah. So attribute data, let us pull out one of the attributes from your X factors. You gave me some X factors here. You said incomplete document. Yeah, so document, this is attribute data. Say report generation time, it continuous data, meeting time is continuous data, but incomplete documentation is attribute data. Or let's say if I take manpower, available, not available, yeah, or a low, medium, high. These are all categories. So let's take two of them. So one is documentation, and one is let's say manpower. Okay, complete documentation and manpower. Yeah. So easiest measure of any attribute data is binary in nature. I was talking about binary in nature means yes, no, pass, fail, presence or absence of that attribute, whatever attribute you're trying to measure, presence or absence. Like happiness. Someone say, I cannot measure happiness. Well, you can. Put attribute is happiness. Category is happy, not happy. Yeah. We'll take that as well afterwards. So documentation, complete, incomplete. And then I have a count. Count means I checked in the last 10 inspections, 6 times the documentation was complete and 4 times it was incomplete. So I have measured my documentation completion process, which might be affecting my overall inspection, which might be affecting my overall project implementation of the power plant. Yes, all are related. We are working on all the factors so that we ensure that the final project is completed on time. The another one was, I think, manpower. Manpower. So I can have 3 categories: very low. Nowadays, maybe it's low, medium, and high, full. Or say high means full. Maybe instead of full, high, I should write full. Anyway. So in the last 10 inspection, or let's say 20 inspections, I found that, oh, there was very low manpower in 5 times. Most of the time, we had medium manpower, and 5 times we are full. Yeah. So this was a full manpower. So low, medium, and high. Yeah. Now, I cannot make a histogram here because it's attribute data. I can represent this as a bar chart or pie chart, like documentation. 6 times complete, 4 times not complete. Or pie chart. 40% complete, incomplete, and 60% complete. So I cannot make it will not follow a normal distribution. It follows some other distribution. We call it binomial distribution, which is of course beyond the scope of our discussion today. So it doesn't follow normal distribution, but just for the time being, we just understand. So here I will express it still, but I will express this differently. So this is how I express what is the performance of my X and Y factors. Now I want to improve my Y factor, the inspection time. Now I need to write one more factor, let's say report generation time. It is taking, let us say, 4 hours. I think you must be taking 3 hours to 4 hours to write a report. maybe 2 hours, 3 hours, let's say 3.6 hours, just to make it a decimal, just to emphasize that it can take up a decimal place as well. So report generation time. Yeah. Now, if I want in Lean and Six Sigma again, there are two types of statistics: descriptive statistics and inferential statistics. Descriptive and inferential. Descriptive means it just describes your state of the process, and the inferential, it tells you how the factors are related. So if I just tell you that inspection time in my company is on an average 12 hours and standard deviation is this is just descriptive status. This is how my process is behaving today. It just tells you that this is what I am. It doesn't tell you why it is like that. Why this inspection is 12 hours. Doesn't tell you that. If I want to establish the relationship of this Y with the X factors, we call it as Y is function of X. Yeah, Y is function of X. So if you want to establish this relationship with the X factor, like say, is the delay in inspection affected by the report generation time? That means I'm trying to establish a relationship. Is my inspection time affected by report generation time? Are they related? So we create a hypothesis. Null means not related, alternative hypothesis, yes, related. And when both are continuous data, if the data are continuous, I use a tool called scatter plot. So here, inspection time and report generation time, both are continuous data, C and C. I can use a scatter plot. If I find some relation like this, I will say, yeah, they are related. I can even get some correlation coefficient, which are, of course, there's no time to discuss all that stuff. I can even get a regression equation. I can say in the form of y is equal to a plus bx. I can get a regression equation. Of course, I'll not be able to discuss too much about it at this point of time, but I get an equation. I can even predict. Depending on how much time you generate a report, I can predict, like your inspection time. And in just one click, you will get it. Inspection time is equal to 5 hours plus 2 times report generation time. So if I'm taking 1 hour to prepare a report, I can say that my total inspection time would be 7 hours. If I'm taking 2 hours to generate a report, I'll say my inspection time is 9 hours. Just fit in this. I can start predicting. So these equations exist in your processes. And these equations can be easily generated on Minitab. If time permits, even I will show that also, but depending on how much time is there left after we finish our yellow belt agenda. So this is how you do a root cause analysis. I will say, yeah, report generation is a root cause. It is affecting my inspection time. But suppose this was the case. Let us take another example. Let's say documentation time with the report generation time. Documentation time and inspection time. I'll say, oh no, there's no relation. Documentation has nothing to do with the inspection. They are not related. But report generation is the root cause, while documentation is not the root cause. Yeah. Then let us look at another. What about manpower? Is it impacting my inspection? Or incomplete documentation? Is it impacting my inspection time? So one is attribute and another is continuous. I cannot use a scatter plot here. It's a documentation, right? If I take in documentation, so inspection time and documentation, complete and incomplete. So if I plot, when the documentation is complete, my inspection time is this. When the documentation is, I see here also I'm doing something similar, but I've restricted now it's not continuous data, isn't it? It's just two categories. So I can't put dots anywhere here, but I have to restrict myself here only. And the inspection time. And you can put this in the form of box plot. You call it box plot. Here it appears that incomplete documentation is delaying my inspection. Here, if I take manpower, again it's attribute data. This was also attribute data. This is continuous data. So I cannot make scatter plot again. I have to make a box plot. And let us say this is the case. Well, manpower doesn't appear to affect. Like even I have full manpower. Okay, high, medium, low. Let us say low also. Little bit it is going high, but it's not a root cause. So manpower is not the root cause. Look somewhere else, because even if I have full manpower, still I'm taking 12 hours. I have less manpower, still I'm taking, let's say, 10 hours or 11 hours. It's not the root cause. It is affecting. It is affecting definitely. It's not the root cause. As per the data I'm showing, maybe reality may be different, but so how I collected the data, so what's happening? I'm trying to prove each of the X factor. I'm trying to correlate to Y. And finally, I'll give you the root cause based on the data and some p-values, which of course we can't discuss here right now. So we will be telling, or as a green belt or a black belt, you tell, well, this is the root cause. Incomplete documentation is the root cause. Data, just 15, 30 samples, 30, 40 samples, good enough. And then it will tell you the whole story. So this is what, we had completed at the define phase. Now let's move on to the measure phase. We collect the data. In the measure phase, we collect the data around 15, 30 samples. They collected 47 samples. We also identify a defect. What is a defect? Defect from customer's perspective. So here we have a defect defined as any recruitment taking more than 60 days is a defect. So they have 27 such recruitments, which are defects. In our inspection, we can say any report inspection along with the report taking more than 10 hours is a defect. So we can count how many defects are there. We can also plot a histogram, which we can do. Just one click, you can get a histogram. Don't worry about this. As a green belt or black belt, you learn these tools and techniques. You learn Minitab. We give you Minitab free of cost during the training, and we also train you in how to click the right buttons. Now we have DPM, or defects per million opportunities. Now we calculate the sigma level. So at 6 sigma, you are having 3 defects in 1 million opportunities. So in 1 million inspections, how many inspections will be delayed? Here in 1 million, if we had 1 million recruitments, so instead of percent, we are doing per million. Especially the million is coming from those areas where, critical processes, production units, critical components being manufactured, airline industries, healthcare, medicine industries, or the surgery, all these critical processes. You can't have and I'm 98% good. 98% good means two people are dying in 100, which is really not good. So you would like to have, 99.999 something. So we count in terms of per million. So not necessarily in your process. In your process, we can express in percentage also, but let's say it's a standard version. We say defects per million opportunities. So every defect per million opportunities corresponds to one particular sigma level. Higher the sigma level, lesser is your defects. Lower the sigma level, more is the defect. So for example, at 6 sigma, you are at 3 defects per million opportunities. Now here we calculated, and what is the sigma level? It is 1.14. So I will not be able to tell you how to calculate sigma level in this limited time, but there's a method, just you learn in not more than half an hour. That completes our defined measure phase. Now we know where we stand. Now we would like to know why we stand like that. Means why we are performing like that. Why our recruitment is taking 60 days, more than 60 days. Why our inspection is taking 12 hours. So map the process in detail, very much detail. By doing Gemba investigation, Gemba means go to the field. See how people are doing the job. You'll find lots of things are taking place which are not adding any value. Identifying value and non-value added activities. Identify the waste. Then you can say apply escape technique, ESCAP, as we're talking about. So can I eliminate? Can I simplify? Can I combine? Can I automate? So there are lots of techniques we teach you in the training. So you can compress the process. So instead of taking 12 hours, it will reduce to 3 hours. Instead of taking 20 days, it will reduce to 2 days. So you'll find lots of wastes in that process. That's what they did. Plus, they also made a cause and effect diagram. You invited all the people. The way right now I did, I asked you some of the causes. You gave me the causes. So similarly, everyone gets a post-it notes if it's a classroom, and then they put all the whatever comes to their mind, all the possible causes on the wall, and you get all the causes. And then there's a method, man-machine material method, measurement, and environment. So it is said that it was Ishikawa was the first time he used this cause and effect diagram, or fishbone diagram, also known as. It looks like a fishbone. He said that if you just brainstorm on these 6 categories, you will get all the possible causes in any domain, any industry, and any process. So that's what, if you want to brainstorm on all the possible causes, you can always use the 6 bones, man, machine, material, method, etc. That's what they did. Then they voted for the causes. Say 5 votes to everyone. So everyone has 5 votes. They put their votes on some of the causes. After voting, you arrange the causes in descending order. This is what they did. They applied Pareto principle. Pareto was an Italian economist who found that 80% of the wealth in Italy is with 20% of the people. He called this 80-20 rule. So Joseph Juran, he applied this to quality, and he said 80% of a problem, here delay in recruitment, or in your case, delay in inspection, is due to 20% of the causes. So you may have listed 10 causes, but only 2 are mostly affecting 80% of your taking their 80% of your time. So try to improve that. So they did that. They applied the Pareto chart. In just one click, you get a Pareto chart. If time permits, I will show you that as well, how to draw Pareto in Minitab. But it's just very easy. It's not very difficult. So here, or I will send you another video where all these things are being displayed. So if you see, this cause is contributing 48 times. Second is for 31 times. This 30 times. The percentage contribution is also listed here. And then first 2 together are contributing 34%. So this is the cumulative line. This is the cumulative line of your Pareto chart. So if you see, the 80% belongs to these first 4-5 causes. So these 4 to 5 causes are responsible for 80% of your problem. So we'll focus on this. We generate ideas. We learn some tools and techniques, and our green belt and black belt, you learn lots of tools and techniques to generate out of the box, good ideas, brilliant ideas, very quickly in 30 minutes, how to generate 108 ideas using, let's say, 65. 6 people write 3 ideas in 5 minutes on a piece of paper. Then they exchange their paper. Again, the next 5 minutes. So you look at these 3 ideas written by another person, and then this triggers new ideas in your mind. And in the next 5 minutes, again, you write 3 ideas. Everyone writes 3 more ideas, adds on to those previous 3 ideas. And this goes on. And then after 30 minutes, you'll get 108 ideas. So similar techniques you learn. And they applied these techniques, and then they generated lots of ideas. After that, they chose the idea. They use the 6 hats technique, prioritization metrics, Pew metrics to identify which is the best idea based on certain criteria. And then they implemented those ideas. And of course, once they implemented, they were able to reduce the recruitment time. And of course, you would like to sustain the gains for a long, long time. So that was improve phase. Now you would come to control phase. You would like to control the process. You would like to have this improvement for years to come. It should be part of your DNA of a process. It should be like part of your company. So how to make it? So you put a review system in place, control plan in place, control charts in place, and that's what is done in control phase. So before, 62% of the recruitments were taking more than 60 days. Now 15% of the recruitments are taking more than 60 days. So this is how a typical project is done. Let me see if there's some time left. Oh, good time left. So I can let us do some Minitab, unless you have any questions. So I'll show you some Minitab. Can you consider, Ahmed is asking, can you consider more than one cause and relate to the impact at one time? Yes, very much. Right now I considered more than 3 causes and related to inspection time only. So I said documentation, manpower, reporting, report generation, all impacting inspection time. Yes, we can do that. More than one cause also. You can do multiple regression. Okay, so if you remember, you gave us a cause and effect diagram. So we have generated, it's not a big deal, you don't be surprised by all these things. It just takes few minutes. And if you learn Minitab, it's also, you'll also know all the secrets, all our secrets. So he just put under man, these 3 and etc. So can you quickly make a cause and effect diagram?
Yes, sir.
So he can just quickly make a cause and effect diagram. And these are the, so I will not describe the process, obviously, just keep making. So we're just putting the relevant columns against the relevant respective labels. And then, the effect, just write inspection delay or inspection time. Inspection delay is good enough. Yeah, that's it. Don't worry about the title. Say okay. So we have got the cause and effect diagram. Now I give this cause and effect diagram to all the inspectors and say, next time, whenever there's a delay, can you please assign a reason? Any one of the reasons, okay, out of this. And then they help us to generate data. And can you go back? And we have reasons for delay. So we have reasons for delay, and we have got some reasons for delay. So first, if you see, first inspector said incomplete documentation. Second was report generation time. Third was incomplete work. Site not ready. So many things they have generated. We can quickly make a Pareto chart on it. Yeah, that's it. Just click. So we have a Pareto chart, and it tells us that first 4 causes, let's say incomplete documentation, manpower, report generation time, and documentation. These 4 are contributing to almost 80%. You see this down below, if you can take the cursor to the count, yeah, 14 times this, which contributes to 20%. then second. So first three are contributing almost 65%, which is also fair. First five also we can take. So these are the, our top 4-5 causes. Okay, let's go back. Now, if I go towards, so let us generate some data, go towards the right side. Oh, wow, you have generated the data. So we have got some data. So let's say inspection time. I just want to know, there are some basic rules. If you remember, I said continuous data, we can make a histogram. Okay, so here, or inspection number instead of ticket number, we can say inspection number. That's okay, it doesn't matter, okay. So inspection time, we can make a histogram. Can you quickly make a histogram on inspection time?
Yes, sir.
So we can make a histogram. So this is all very easy, and for people working in SEC, it's like very much easier. So, and I was able to, yesterday I checked with your training manager that who are the people who are attending this session. So when I came to know that your profile, so I said, well, I can give you more. Otherwise a yellow belt is like very basic. We talk about DMAIC or what are the simple steps, etc. But I thought giving you more. So here you have average 303 whatever some minutes. Okay, maybe you're talking about any. This is not some number. I think we have not changed the numbers. Doesn't matter. So and standard deviation is some number, and then this is your histogram. And can you go back? Yeah. Now, is inspection time affected by my let's say documentation? So let us see. Inspection time and documentation. One is attribute, one is continuous. I will make a box plot, if you remember. So I'll make a box plot. Oh, it is not affected. Okay, fine. And how about the manpower? Yeah, it appears to that it is affecting. Now here, of course, we have just quickly generated the data, so the things might not make sense here, but I think you got the picture. So we can get the right, you can go back. Similarly, report generation time and documentation time. Now let's say inspection time versus report generation time. Are they impacted? So let's do if both are continuous data, we can make a scatter plot. So inspection time versus, let's say, documentation time. Yeah, of course, it is affecting. And how about and we can do a regression also. Can you please do a regression? So we have an equation with a good R square of 98%. So it's like very good equation, which, yeah. So we have got a regression equation. I can start predicting. I can put multiple regression. I can put other variables also. Yeah. Can you go back? And then finally, let us do the inspection time with the other one, report generation. Yeah. So is report generation, like, are the engineers taking more time to write the reports, or inspectors taking more time to write the reports? And it is affecting. So in this case, I will do a scatter plot. Again, one more time. So report generation, oh, it's not affecting. Means report generation time of the inspector is not the root cause. Means we should not focus too much on that. We should not try to tell them improve that. We should not do Gemba investigation there, try to reduce the non-value added activities there. But the documentation is critical. So that one is something. So I think you got the idea. It may not be necessarily relating to what you are observing in the industry, but we just generated just to quickly show you the capabilities of the whole green belt and black belt trainings. So yeah, that's it. So yeah, we have done real good. Now we have 15 more minutes for answering the questions. So please let us know if you have any questions. Can we use multiple regression including qualitative data? Yes, of course. Well, let us show that. Can you show Ahmed? Yes. Anil, you can share your screen. Yeah, so I can do, there are two ways of doing it. So I will put all the things, inspection time, documentation time, report generation, documentation, manpower. So for that, I'll have to just generate indicator variables. We call it indicator variables. So, so now what we are doing, so because it's attribute data, I have to do some, arrangements. Yeah. Now let us create the indicator variables. So go to calc, make indicator variables. And for, let us say, what you want, documentation, C29. Select C29. Yeah. And in columns, just replace that. Yeah. Here, just write C30. Click OK. Yeah. So we have indicator variable, you see. So I'll not be using C29 column now. I'll be using C30 or C31. So when it is complete, the value of complete becomes 1 and incomplete becomes 0. Yeah. And similarly, I'll create the indicator variable for this also. But just for the, in the interest of time, I hope, okay, please quickly do it. Yeah, please quickly do it. Yeah. For manpower. High, no, here you have to put high. High for high, right?
Yes, sir.
Yeah. Yes. So now we have got this anyway. So just do multiple regression, go to stat, regression. Yeah, fit regression model. Inspection time, here put report generation, that's documentation, report generation time, yes, documentation time, select L, C26, C27, and C30. No, not H, only one less, right? And complete, yeah, C30. If it's the attribute data, we have to choose n-1 in our equation. There's no time to just tell you why, but yeah, because there is no point in putting both the variable because it is not going to add any information. Click OK. So you have got the full equation. So now let us predict if the numbers were correct. Obviously, we have just put some numbers at random, but if the numbers were correct, if the documentation is complete means value of complete will be 1. So 3.38 multiplied by 1. Suppose the documentation is not complete, the value of complete becomes 0. So I'll put 0 there. Then similarly, I'll put for values for L and M. If it is manpower was low, I'll put L1 and M 0. If manpower is high, L and M both will be 0. Yeah. And then documentation time I put and report generation time, and I get the equation. Thank you. Any next question? Any other question? That was a very good question, very advanced question, Mr. Ahmed. Wow, great! You're simply good. Appears that you've already done your lot of homework, or you've done some. You're aware of that multiple regression. You should go for a black belt then. So just to tell you that while you're thinking of question, we do run green belt and black belt programs, and due to the present situation, the COVID-19 situation, and it's a blessing in disguise, I would say. So we have come out with these and we have found that online trainings are much more effective, the live trainings we are talking about. Otherwise, I can send the recordings to you and all that stuff, but which will not be like, very relevant to your industry, or you will not be able to interact. But the way we interact in classroom, we are interacting, I think, sometimes much better way than in classroom. Just to demonstrate that online trainings really work. Training is effective, are effective, without waste of transportation, going to a classroom and lots of stuff. If you are interested, most welcome. You can always come back to us. Your training department can also come back to us. And if you're finding it effective, you can inform your training department that, well, we like the training, or maybe we dislike the training, whichever, whatever it is. And based on that, we'll be happy to serve you. I'm missing my Saudi trips. Of course, Anil is in Saudi Arabia. I took a flight in March, and when I came here, the whole thing, all flights were shut down. So now I'm stuck outside Saudi Arabia, but definitely you won't miss me. Yeah. So we have started doing the trainings online, and they are very cost effective too, from every perspective. Say thank you. Thanks a lot. It was nice interacting with you. I'm Amitabh Saxena. You can connect with me on LinkedIn. You can connect with me, Amitabh, Amitabh, Saxena. You can connect with me on LinkedIn. You can connect with me on, there's a Facebook page, Anexas Europe. LinkedIn also, Anexas Europe, the same name is there. You can get associated with us. You can also you can subscribe to our Anexas channel, where I keep putting videos of different tools and techniques in bits and pieces, like FMEA, cause and effect, p-values, etc. You can have a look at those. I will share one yellow belt training with you, which is not this one, this recording, but some other recording, where I have also talked about some other tools using some other example, although it will be similar in nature. So you can revise whatever we have learned here. You can revise. Of course, I have taken another example from another industry there, but obviously for Lean Six Sigma, green belts and black belts, everything is a number, either continuous or attribute. That's it. And we have to apply all the same tools of box plot, scatter plot, regression, ANOVA. Instead of box plot, we could have applied ANOVA also, analysis of variance. Both are attribute, we apply chi-square tests. So all these things are they are all interesting. We make it interesting. It's not at all difficult. People sometimes say, oh, Lean Six Sigma is very difficult, very boring. There are two things. Oh, Lean Six Sigma is not for us. Oh, it's difficult. It doesn't apply to our company, or our people will not be able to learn it. No way, you have seen. I've almost taught you some green belt and black belt tools. I'm sure it was very easy for you. It depends on the trainer also, by the way. Yes, a little bit of marketing. So yes, so we hopefully, would like to definitely hear from you. So with that, let us close the meeting.